Hello, hello. Today we would like to present our project, CSIT 040 Final Assessment. The topic is number 4, Clustering AI, presented by Omar Amr, Amr Arar, Yusuf Sharif, Muhammad Walid, Hamza Abu Nar, and Umar Zahran. Hamza.
The research investigates a rock dataset which contains measurements of rock dimensions and color properties. The K-means clustering algorithm helps identifying natural clusters from rock physical attributes while investigating color relationships with these clusters. The project evaluates clustering performance through two validations methods, which include the elbow method and chi-square testing.
The solution.
So for the solution uses a structured data analysis workflow to identify natural groups in the rock dataset and determine whether these groups relate to rock color. First of all, the data is prepared by extracting the numeric features, which are the rock length and weight. These are required for clustering, while the rock color is kept for later comparison. The number of clusters is chosen using the elbow method, which showed that 3 clusters best fit the data.
K-means clustering is then applied with K equals 3 to group rocks based on their physical characteristics. The resulting clusters are visualized with scatter plots, along with the cluster centroids, allowing clear interpretation of each group: small, light, medium, large, heavy rocks. A second plot shows the distribution of rock colors in the same feature space.
Finally, a chi-square independence test is used to evaluate whether rock color is statistically related to calcium membership. This structured design ensures that the findings are objective, interpretable, and supported by both visual and statistical.
Switch the slide. So the first graph, which is the elbow method plot, helps us decide how many clusters we need to use for k-means. As k increases, the total distance decreases. The clusters becomes tighter. But the improvement slows down at a certain point, which is the elbow. In our case, the elbow is likely to appear around k equals 3. Next slide. So this is the k-means cluster visualization, the length versus weight. The x-axis represents the rock length, whereas the y-axis represents the rock weight. Each point is colored based on the cluster assigned by k-means. Large X markers show the cluster centroids. This graph visually shows how k-means divided your data. The first cluster number 1, no, don't switch now. The first cluster, or cluster 1, is small and light rocks. Cluster number 2 is medium size and weight. They're not so heavy, not so light. And the third one is the large and heavy. The big axes represent the average rock in each cluster. The next slide, please. Graph 3 represents rock color distribution, which is length versus weight compared to color. It lets us visually compare. Does color relate to physical characteristics like length or weight? If we look at the patterns, like for example, if green rocks appear mostly in heavy regions, color may be related to weight. But if each color is spread everywhere, which means colors random and is not related to size, which appears in our graph. Okay. Yusuf.
The solution can be improved by standardizing the data before clustering, exploring many advanced clustering methods such as DBScan, GMM, or hierarchical clustering, and adding additional rocks features for richer analysis. Cluster quality could be evaluated more thoroughly using silhouette scores, and increasing the dataset size would strengthen statistical reliability. Visualize, visualize, Visualizations can be enhanced with 3D plots and heat maps, and further investigation into connection between rock color and physical properties could be provided deeper insights. Finally, automating the workflow could make the analysis more efficient and reproducible. Thank you for your attention.